Another common question is being asked to sketch a magnetic field. So it could be a magnetic field from a bar magnet, or the magnetic field from an electromagnet, a solenoid, or simply the magnetic field around a wire, a conductor carrying a current. And you need to be able to show what the differences are. So let me try to sketch a bar magnet. So a bar magnet itself will simply look like a long rectangle, and you'll have a north pole and a south pole. So that's your magnet itself. Now what they're interested in is the magnetic field. So you want field lines that go from one pole to the other. They need to be approximately symmetric. And you would try to show that the direction of the field lines is from the north to the south. Okay, so that's the electric field lines around a bar magnet. So you need to draw a rectangular magnet and make sure you show the north and south poles. Now a solenoid is very similar, except there isn't a bar of metal. What you have is a coil. So you have a wire that coils round. So it looks something like that. So it's just a coil of wires. I haven't drawn that very well, but you get the idea. You have a coil of wires, and you have a current passing through that wire. And as a result of that current, you're going to have, again, a north pole and a south pole. Now, which end is north and which end is south really depends on which way around this current goes. So you've got, that's one way to remember it. So if you were to look at the solenoid from the side, from the end, the south end, the current is going clockwise. So in this case, I think it's the other way around. So you'll have the south pole here and the north pole here. And what they want is the field lines. So your field lines are always going from the north to the south. It'll look very similar to a bar magnet, except you'll have these lines inside. All right, so it's from north to south. And it's the same. Try to make it symmetric, and it'll look something like that. So that's how you would draw the field lines around a solenoid. So it's very similar to a bar magnet. That's if the current is going in one direction, if it's not alternating current. Now, if you have a wire, I suggest the best way to draw this is to draw a piece of paper or card, so a rectangle, then draw your wire as a vertical line passing through that. So this is my wire, dot, 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 there. So that's my current passing through the wire. Now, they're not interested in the current, they're interested in the magnetic field lines. So with your right hand, if you point your thumb in the direction of the current, you'll see that the magnetic field lines will go clockwise around the wire. So you'll have concentric circles that look a little like that. Okay, so make sure you show that there are circles going clockwise around the wire. That's the difference between a solenoid and a wire. So the magnetic fields here, they're mostly parallel, but here you have this circular arrangement. So in case you're ever asked about that, be prepared.